All right, hello there guys. Today we are learning how to solve quadratic equations with completing the square. All right, so far we've learned how to factor and how to solve using square roots. And those two methods are pretty nice and they're pretty efficient, but it doesn't work all the time. So for square roots, what needs to happen is that there only needs to be one x term, so that works great for something like x squared minus 8 equals 0. Or 3x squared plus 5 equals 0. Anything like that where there's only one x term. And then factoring, for example, that's a type of factoring. We have difference of squares, that's a type of factoring. We have take out a GCF, that's a type of factoring. But what happens if it doesn't fall into one of our factoring categories and there's more than one x? What do? So these two methods actually work every single time. They're not as efficient, they're not as quick, but they do work every single time. So today we're going to learn about completing the square. Completing It's okay. It's okay. Completing the square is a method that you very much want to follow step by step. Okay, so right here, step 1 says to move the constant to the right side if needed. Okay, so the constant, this is our review of vocabulary, the constant is a number without an x. So the constant in this case is the 3. So I need to move that over here to be by itself. So I'm going to subtract the 3. Like so. Okay, so this is always the setup you want. You want your constant over here to the right. Check that off. Step 2, divide by the leading coefficient if it isn't 1. So the leading coefficient, again, vocabulary, is the number in front of, that's technically the number in front of the term with the highest exponent, but all right, it's the number in front of the x squared. So in this case, there isn't a number, therefore it is automatically 1. So I don't need to divide everything by 1. That's not going to do anything. That's why it says if it's not already 1. So I could check that off because in my case it's 1. Okay, step 3. Take half of b. All right, so in our original problem, this is a, this is b, and this is c. We've talked about that when we graphed quadratics. So half of b. So over here, half of 4 for this problem. So take half of b, half of 4 is 2. And then we also have to square it. So now I'm going to take 2 and I'm going to square it, and I get 4. And then that's the number that you add to both sides. So I'm going to add 4 to both sides. All right, so half of b, square it, get that number, add it to both sides. So I come back to my equation. Okay, and on both sides, I'm going to add that 4. Okay, it's completely legal as long as I do it to both sides. Because again, if I subtracted the 4 away, it would be the same thing. Okay, so I took half of b and squared it, done. I added it to both sides, done. Okay, factor the simple trinomial on the left side. So look at the left side only. X squared plus 4x plus 4, and look at it as a simple trinomial. So we want to find factors of 4 that add or subtract to be 4. So we have 1 and 4, 2 and 2. So which of those factors could add or subtract to be 4? And the answer is 2 and 2. So you set up your 2 parentheses like we always do for simple trinomials. We do x and x in the front. We found our factors are 2 and 2 in the back. And then I make a positive 4 in the middle. They both have to be positive. And over here, I just did negative 3 plus 4, which is 1. Okay, so factor the simple trinomial on the left side. Okay, so this right here is special. The x plus 2 times x plus 2, that can be written as x plus 2 squared. Technically, I don't have a step for that. So if you wanted to make a step 5.5 or whatever, you could say write the factors squared. Okay, I didn't really make that a step, but kind of goes along with factoring. So you factor, and then we have two of the same factor, so I write it as that factor squared. And that's the magic right there. What just happened right there is magic, because now I can solve using square roots. At the beginning, I couldn't solve using square roots because I had too many x's, but now I can solve using square roots. So I get rid of the squared by square rooting. The square root of 1 is plus or minus 1. And then I subtract the 2 and put it in front of the plus or minus. I can figure out what negative 2 plus 1 is and what negative 2 minus 1 is, so I need to keep going. So we get negative 1 and negative 3. Okay, completing the square is a pretty lengthy process, but it's also really repetitive. It's kind of like the process of like factoring complex trinomials, like with grouping. It's kind of like that, where it's like at first it seems overwhelming, but then it kind of gets pretty repetitive because most of the problems look pretty similar. All right, don't worry if you don't get it yet. That was just the first example. Let's try another one. Okay, the steps are going to be your friend. Okay, when students are like, I don't get it, I'm going to be like, okay, what's step 1? Move the constant to the right side. Well, technically there's a number over there, but this is also still a constant, so I actually need to move this over to the land of the constants. I call this side the land of the x's, and I call that side the land of the constants. Okay, they don't like each other. They want to be on opposite sides. Check. Divide by the leading coefficient if it isn't equal to 1. So our leading coefficient is the number in front of the x squared term. It's 1. I don't need to divide everything by 1, so check. If you want to divide everything by 1, you're welcome to. Take half of b. Okay, so I look at my problem. A is 1, b is 6, and c is negative 5. So my b is 6. So over here, I want half of 6. That's 3. But then I also have to square it. So I have 3 squared, which gives me 9. So half of b, 3. Square that number, get 9. And that's the number you're going to add to both sides in the next step. So we're going to add 9 to both sides. So now I finally come back over to my problem. And I'm going to add 9 over here on this side, and I'm going to add 9 over here on this side. You got to do it to both sides, just to be fair. So check. Factor the simple trinomial on the left side. So just look at the left side and ask yourself, what are factors of 9 that add or subtract to be 6? So factors of 9 are 1 and 9, 3 and 3. Which of those could make 6? That'd be 3 and 3. So you set up your 2 parentheses. That makes 4. You put an x and an x in the front. You put the 3 and the 3 in the back. And I'm trying to add to be a positive 6. These are both going to be positive. Okay, and that is where the magic happens. That will happen every time, where it's called a perfect square trinomial. That's where both of these will end up being the same. So I can write x plus 3 times x plus 3. I can write that as x plus 3 squared. And that's the trick. Seriously, like a math trick, kind of. Because now that it looks like this, that should look familiar. That's solving using square roots like we learned last time. So I can get this x by itself. I first get rid of the squared by square rooting. This is plus or minus 2. I need to move over this 3. I'm going to subtract the 3. I'm going to put it in front of the plus or minus, so I get negative 3 plus or minus 2. Okay, I can keep going because I can figure out what negative 3 plus 2 is, and I can figure out what negative 3 minus 2 is. So I get the answers of negative 1 and negative 5. So hopefully you can kind of see the process is pretty repetitive. Once you get the setup here, It's like you add that number to both sides. This ends up being a double. You write that squared. You always square root next, and then you always move the number next. It's very like the same. All right. At this point in time, I would suggest that you pause the video and kind of try to start the next one on your own. I'm going to keep going, but that is always a good option and a good thing to test yourself on. See how far you can get. All right, move the constant to the other side. Subtract 12. Check. Divide by the leading coefficient if it isn't 1. It's 1. Don't need to do that. Half of b. b is 12. Half of 12. Technically, b is negative 12. Technically, but I'll show you why it doesn't really matter. So let's say b is 12, because it is. Half of negative 12 is negative 6. But then what do we always do to that number after we take half of it? We always square it. And then what happens when you always square a number? It always ends up being positive. So really, you don't have to really worry about whether b is positive or negative yet, because no matter what, we're going to square it and it's going to be positive. So 36 is the number we're going to be adding to both sides. So add 36 to both sides. So I come over here, I'll leave an opening there, and I'm going to add 36 on the left side, and I'm going to add 36 on the right side. Eventually you can kind of do most of this kind of in your head. You're like, half of 12 is 6, 6 squared is 36. Okay, I'm going to add 36 to both sides. So eventually this can be a little bit quicker, but I still wanted to show my work. All right, so on the right side, that makes 24. Okay. Here, I'm looking for factors of 36 that make 12. Hopefully, you guys have maybe noticed something, that since these have to be a perfect square trinomial, these numbers always end up being the same. So it always ends up being what number times itself gives you 36. Anyway, what numbers add to be 12? That's 6 and 6. I need them to make negative 12 this time, so they both need to be negative 6s to make a negative 12. And again, you actually don't really have to show this work anymore, because hopefully you've realized that you can kind of just take the square root of that number, and that's the number that ends up being here. But I wanted to explain kind of where that came from. All right, this is the magic. X minus 6 times x minus 6 can be written as x minus 6 squared. Okay, so we factored the left side. Check. Solve using square roots. Okay, I'm going to solve using square roots. Don't forget the plus or minus. You could add that here to like your steps. Don't forget plus or minus. Okay, the square root of 24. This is the first time where it hasn't been a perfect square, but hopefully we're not freaking out because we practiced that a lot last time. So 24, you want to try and break it down, see if anything can come out. We get 2 times 24, and 2 times 12, and 2 times 6, and 2 times 3. A 2 can come out of that pairing. Another 2 can come out of that pairing, and then that 3 is still stuck inside of the square root. So we get plus or minus 4 square root of 3. That's what the square root of 24 breaks down to be. And you could kind of go over here on the side and do that if you don't want to, like, you know, make this like this. You can come over here and figure out what it equals and then just put it back down here. I still have to add the 6. I still put it in front of the plus or minus. So we get 6 plus or minus 4 square root of 3. Okay, there's a lot of skills needed in this problem. We needed to know how to factor a trinomial. Okay, we needed to realize that this is the factor squared. And then we have to be able to do what we learned last time, solving using square roots. And within that, we also need to know how to simplify square roots. So there's a lot being tested on these completing the square problems. Okay, let's do a couple more. Okay, I'm going to kind of work through this one pretty fast. kind of do a little bit more in my head just so you can kind of see that it can go a little faster. Move the constant to the right side, it's already there. Divide by the leading coefficient, that's 1, don't need to do that. Half of b and square it. b is 10, so half of 10 is 5, and 5 squared is 25. So 25 is what I'm going to be adding to both sides. Add 25 there, add 25 there. On the right, that makes 29. Here I'm looking for factors of 25 that make negative 10. Okay, I want to know a number times itself to make 25, so that's going to be 5 and 5. I do want to make negative 10 in the middle, which means both need to be negative in order to make a negative 10. That's the magic. X minus 5 squared, that's the same thing. And then, so I did that, I factored the left side. Solving using square roots, square root, square root. Don't forget the plus or minus. Ask yourself, can I break this down anymore? Is there anything that can come out or multiply to be 29? The answer is no, it's prime, so you just keep the square root of 29 then. And then I put the plus 5 in front of the plus or minus. Again, if that was a little fast, you're welcome to rewind and kind of go back and go through it again. All right, 2 more problems, mainly just because this is the first time we'll actually have to do step 2, which good news is it's not a big step. So move the constant to the other side, that's the 4, so I'm going to add 4 to both sides. Okay. Then, check, divide by the leading coefficient if it isn't 1. This step, a lot of people forget about because we don't have to do it every time, but it is really important. I can't do this process unless that's a regular x squared in the front. So I need that to just be a regular x squared, which means I have to get rid of that 2. But if I'm going to divide that by 2, I have to divide everything by 2. So that'll make a regular x squared like I want it. That'll make minus 8x, and that'll make 2 over on the right side. So whatever that number is in the front, you have to divide it out all the way through. So now this looks like my normal problem. This is kind of where I was at, like right here at the very beginning of this problem, right? You have the x's on this side. Can't find my paper. You have the x's on this side, and you have your constant on the other, and there is no number in the front. So that's what the 2 first steps are for, is kind of like the setup. Now I can do all the other stuff. This is my b. Half of b is 4. 4 squared is 16. So 16 is what I'm going to be adding to both sides. Again, I got that because it's half of 8 is 4, and then I have to square that to get 16. Okay, this makes 18 on the right, and over here on the left, I set up my simple trinomial. What number times itself would give me 16? Would that be 4? And then pretty much whatever sign here ends up being in both of those, but how do you make 4 and 4 make negative 8? That's a minus and a minus. It's x minus 4 squared, which now allows me to solve using square roots. Square root, square root. Don't forget the plus or minus. Okay, can I break 18 down at all into a factor tree? Well, I know I can at least take out 2 because it's even. Oh, I know I can break down 9 because it's 3 times 3. Oh, yep, there are 2 numbers. So a 3 can escape and a 2 is left inside. And then I add the 4 and I put it in front of the plus or minus. This process is lengthy, and it does take quite a bit of skill, but it is repetitive. I really find that the more you do these, the better you get. The more it just ingrains into your brain. So the more you do, the better you really do get. All right, got one more problem I'll do real quick. Another one that actually does have a number in the front. Move the constant to the right side. The 15's already moved. Check. Divide by the leading coefficient. Oh, that's 3. There is a number. That means I have to divide all of these numbers by 3. Some people actually will like do this. They'll write the 3 and the 3 under each one so they can see it a little clearer. I'm dividing each by 3. So it's x squared plus 4x equals 5. So after step 1 and step 2, that's what it should look like. X is over here, number's over there, and there is no number in front of the x squared. Half of b, okay, b is 4. So half of b is 2, and then I have to square that. So 2 squared is 4. So I'm adding 4 to both sides. I almost wrote a 4. Oh, my eraser is terrible. X squared plus 4x. Okay, so again, half of b is 2. 2 squared is 4. 4 is what I'm adding to both sides. That makes 9 over there. And then this is my simple trinomial, so I set up my x and my x. And I'm looking for factors of 4 that add to be 4. That's 2 and 2. Okay, we're back to where I actually need a positive 4 in the middle, so that means both of these are going to have to be positive. So I get x plus 2 squared equals 9. Square root. And we're back to a problem where we actually can find the square root of 9. That's 3. Don't forget the plus or minus. I'm going to subtract the 2 and put it in front of the plus or minus. And then because this is a regular number, it's not a square root, I actually can do -2 plus 3 and -2 minus 3 to get my answers. So I get 1 and -5. Okay. All right, on your homework that I created, I did make the homework matching. So you actually have all the answers there. You just have to find out which one it is. Of course, you still need to show your work. But I did that just so you could feel a little bit more confident and knowing as you went through whether you were getting things right or not. So kind of use that, but try not to use it too much as a crutch. And make sure you, especially on this, you guys, you got to show your work. You got to show all of it. So, all right, good luck.